Hi, Bobcats. This video is going to work a few more examples of calculating the oxidation number on an atom. To recap the last video about how you do this, if we have an element in its standard form, so something like oxygen gas or iron as a solid, the oxidation number will be 0. If we have a monatomic ion, something like the chloride ion, its oxidation number will be equal to its charge. And then there are 3 elements that we have rules for when they are in a compound. If it's hydrogen, its oxidation number in a compound will be +1. If it is oxygen in a compound, its oxidation number will be -2. And fluorine will be a -1. Keep in mind that that's only when they're in a compound. If it's the element all by itself, like H2 gas, its oxidation number is 0 because the first rule, the element rule, applies. For all of the other elements that we don't have an explicit rule for, we're going to use the idea that if we add up the oxidation numbers for every atom in the compound, it should equal 0. So that's for a compound. And if instead of a compound, we're working with a polyatomic ion, when we add up the oxidation numbers for every atom in that polyatomic ion, it should be equal to the charge. So that's for a polyatomic ion. So I'm going to demonstrate over the next few slides this process that just kind of formalizes this idea that when we add up all of the oxidation states, it'll equal 0 for a molecule, or it'll equal the charge for a polyatomic ion. And the thing I like about this formalism is that along the way we separate out the subscripts on the atoms from their actual oxidation number, so it's really clear the role each number is playing. Because when we're asked in a multiple choice setting, what is oxidation number on this atom in this compound or in this ion, it's the thing that we're going to be drawing in boxes that we have to answer with. And very often students will want to multiply that by the subscript, and that's not what they're asking for when they ask those questions. They're asking for the oxidation number on just one of those atoms, even if there's a subscript on it in the formula. So we're going to break down the formula by element. We're going to draw a box that's going to represent the oxidation number. We're going to multiply that box times any subscript that's in the formula, and then we're going to add all of that up and set it equal to 0 for a molecule, or we'll set it equal to the charge for a polyatomic ion. Then we basically have an equation. We solve it for whatever's unknown, and we'll learn from that process what the missing oxidation number is. So here are 2 examples. The first one, chlorate, is a polyatomic ion. The second one, dichlorine trioxide, is a molecule. So the sum of oxidation numbers will be different for these 2 species. So on this slide, I'm going to work out the first one, the chlorate ion. And so I'm going to start by kind of rewriting that formula, but splitting it out a little bit. And above each element, I'm going to draw a box. Whatever we put in that box is going to be the oxidation number on that element. And I'm going to also multiply each box times the subscript that's on it. Well, for chlorine, there's no subscript written, so it's understood to be a 1. Multiplying by 1 doesn't change anything, so I'm not going to write that out. But oxygen has a subscript of 3, so I am going to write that out. We're going to multiply this by 3. Now for the oxidation numbers, oxygen in a compound has an oxidation state of -2. Chlorine, well, we don't have a rule for that one, so that's actually what we're going to try to find. So I'm just going to leave our unknown as Cl. If you're more comfortable putting an X or something like that in there, go for it. And then we're going to add this up. The oxidation number on chlorine plus 3 times a -2 has to equal the charge, because this is a polyatomic ion. So just to clean that expression up a little bit, I'm just going to rewrite it. I'm going to say chlorine's oxidation number plus 3 times a -2 is equal to a -1. Well, 3 times a -2 is a -6. So this is the same thing as Cl. -6 is equal to -1. So to get the Cl by itself, I can add 6 to both sides of this equation, and I get that chlorine is a +5. So in this compound, the oxidation numbers are a +5 for chlorine, and oxygen is a -2. So those are the oxidation numbers for the elements in the chlorate polyatomic ion. In this second one, the neutral compound dichlorine trioxide, if we split that formula out, we get Cl2O3. So now I'm going to draw a box above each, which is where we're going to draw in the oxidation number. Now, chlorine, we don't know, so I'm going to just leave it as chlorine. But oxygen, when it's in a compound, is -2. And I need to multiply both of these oxidation numbers by the subscripts in the formula. Then we're going to add them together. And this time, the sum has to equal 0 because Cl2O3 is a neutral compound. And the sum of the oxidation numbers of every atom in a neutral compound has to be 0. So I'm going to just take that and rewrite that to clean it up a little bit. We're going to have 2 times the oxidation number on chlorine plus 3 times a -2 is equal to 0. So that's telling us 2 times chlorine, and then the 3 times a -2 is a -6. That gives us is equal to 0. I'm going to add 6 to both sides of this equation, and I'm going to get 2 times oxidation number on chlorine is equal to a +6. Then to get chlorine by itself, I'll divide both sides by 2, so I'll get chlorine is equal to a +3. And by rule, we had that oxygen was -2. So those are the oxidation numbers on all of the atoms in Cl2O3. So I'd like for you to work out the oxidation numbers on all of the atoms in these 4 species: methane, the nitrate ion, nitrogen dioxide, and calcium carbonate. Pause this video, take a moment to work those out, and then come back and join me, and we'll work all of them out together. All right, hopefully you paused this and you worked these out on your own. For methane, CH4, we have 2 elements, carbon and hydrogen, and we'll put a box above H for its oxidation number and a box above C for its oxidation number. Hydrogen in a compound is +1 and carbon is unknown, so I'll leave it at a C. We have 4 hydrogens, so we also have to multiply it times 4. There's just 1 carbon. And then we're going to add all of that up, and we should get 0 because it's a neutral compound. Cleaning that up just a little bit, we've got carbon plus 4 times 1 is equal to 0. So carbon plus 4 is equal to 0, or carbon is equal to -4. And then by rule, hydrogen was +1. All right, so we've got a -4 and a +1 for carbon and hydrogen. In the nitrate ion, we've got NO3. We'll draw a box for each oxidation number. Nitrogen is unknown. Oxygen by rule is -2. We have 3 of them, so we'll have to multiply that by 3. We'll add that up, and it has to give us the charge. Well, the charge on the nitrate ion is a -1. So cleaning that up a little bit, we have our unknown nitrogen plus 3 times a -2 is equal to -1. So nitrogen, and then let's see, 3 times -2 is -6. That's equal to -1. If I add 6 to both sides of the equation, I get that nitrogen is a +5. And by rule, oxygen was a -2. So there are the oxidation numbers on the elements in the nitrate ion. All right, 2 more examples here. We've got nitrogen dioxide. So if we separate that out into the separate elements, and we have N and O2, and I'm drawing a box above each to represent the oxidation number on that element. And then, let's see, oxygen in a compound will be -2. Nitrogen, we don't know, so we'll have to solve for it. And then remember that the oxygen has a subscript of 2, so we have to take into account that there are 2 of those atoms. We're going to add this up, and it has to equal the charge. Well, NO2 is a neutral molecule. There is no charge, so that all has to add up to 0. Cleaning that up a little bit, we've got nitrogen plus 2 times a negative 2 is equal to 0. So nitrogen minus 4 is equal to 0, or nitrogen is equal to plus 4 by adding 4 to both sides of the equation. Additionally, oxygen by rule was minus 2 in this compound. So those are our oxidation numbers. If you look at our previous example, the nitrate ion, nitrogen was a plus 5 in it. The nonmetals will take various oxidation numbers in various compounds, so it's something that you always have to analyze. Then we've got calcium carbonate. Calcium and carbon and oxygen with a subscript of 3. So above calcium, I'm going to put a box. Carbon, we'll put a box, and oxygen, we'll put a box. Oxygen has minus 2 by rule, and we have 3 of them, so we'll have to multiply by 3. Carbon is an unknown, and calcium might at first appear to be an unknown, but there's a rule we haven't used yet, which is that the oxidation number on a monatomic ion is its ionic charge, and this is an ionic compound because it's a metal plus a polyatomic ion, so the ionic charge on calcium is its oxidation number. Calcium is an alkaline earth, which means it's in group number 2, so its charge is plus 2. It's one of the fixed charged metals, so its oxidation number will be plus 2. If we add this up, we should get the charge on the species, which is 0 because it's a neutral compound. So cleaning that up a little bit, we're going to have 2 plus carbon plus 3 times a negative 2 is all equal to 0. Let's see, so this is 2 plus carbon, and then 3 times minus 2 is a minus 6. Combining the 2 and the negative 6, we get C minus 4 is equal to 0, and then adding 4 to both sides tells us that carbon is equal to plus 4. We found by rule that calcium was plus 2, and oxygen by rule was a minus 2. And notice that carbon in this one ended up being plus 4, which was very different from the negative 4 that it had in the compound methane. As we worked through these examples, hopefully you became familiar and comfortable with the process. If you're getting the concept and you're solid on this, you can get to the point where you don't need to draw all the boxes and work all those formalisms. You can just say, oh, okay, calcium carbonate. This is an ionic compound, so calcium is going to be a plus 2, and there's just one of them. I don't know what carbon is, so I'm going to leave it as C, and there's no subscript, so there's just one of them. And then we've got 3 oxygens, and by rule, oxygen is minus 2. And then hopefully you can just go through and solve that a little more easily. If you're not comfortable with this, by all means, draw the boxes. Just do whatever works best for you.